Today we're going to talk about the Checkweigher system I made for my second year lab project. But quick, this video is only made possible by Josh Rankin and Metler to the Customer Support Helpline. Without them, this video would not have been possible. This will kind of be a two-part video, where at the beginning I'm going to give an oversimplified explanation of what's happening. In the second part I'm going to talk about in depth with how I'm getting information out of the Checkweigher and into the PLC. Now let's get back to the video. Important background info. I have a Metler Toledo Checkweigher. I also have L24, ER, and L23E PLCs that I'm using for communication and processing. Along with that, I have an Insight 5000 series vision camera and a PanaView Plus 1000 for my HMI. The plan was the camera takes a picture of the box as it passes underneath, and the load cell will determine the weight. If either the camera or the box fails, then the box will be rejected. If both pass, it will continue along. So, the camera up top is looking down into the box to see what parts are inside. Then we got a beam brake just behind the camera to detect when a box is going over the load cell. Then we got the load cell, then we got a rejector in the back to push off the rejected boxes. So in the bottom right here, my HMI is going to pop up. I'm going to hit the start and stop and start again. And when it'll stop, it was on the beam brake, and even though it weighs a little bit too much, the rejector is going to hit just on time. And because it weighs a little bit too much, I'm going to have to adjust the weight inside the set point, and then I'm going to hit the reset button. You'll see the indicator after I hit the reset button pop up. Now I'm going to place it at the start again, and you should see all the indicators up top come on, and it's going to run through with no problems. I'm going to do it again because this is how it should run with a good system. Everything's set up, it's going to do fine. Here it comes through again. You see all the indicators lit up just perfectly. Falls off. Now I'm going to remove the block from the package, so the cameras can't see the block, and it's no longer going to have the proper weight. Both of those factors combined, none of the indicators come on except the rejector, and it's going to fail. So I'm going to come over here to the set points. I'm going to show you the deadband range where you have the greater than and less than. The weight's not in there, so I'm going to add the block to the box again. So now the camera won't be able to see the block, but it'll weigh the proper amount. And even though it weighs the proper amount, the camera doesn't see it, so the camera indicator is never going to turn on, and it's still going to get rejected. Now I'm going to add the block back to the top of the box so the camera can see it. But unfortunately, this time when I did add it back to the top and put it back to the start, right there my hand hit the beam brake, triggering it a little prematurely, so the weight's going to be off and the rejector swung early. But now I'm going to reset it, and it's going to work out just fine. And there it goes. So this is going to be the end of part 1. I'm going to go into part 2 now, and it's going to be a little bit more in depth on how I connected to my Checkweigher and read the data that was coming from it, but hopefully still somewhat understandable for most people. So there's kind of 4 major steps when you're doing this whole TCP socket client connection. You have delete, create sockets, connect, and then read. So step 1, deleting, kind of cleans up the PLC sockets and just deletes everything, and it's kind of the housekeeping that you need to get done so you don't confuse it later on while you're after creating the connecting and reading parts. If you have different team instances, it can get confused and then it will not function. So creating a socket. When you create a socket, you're kind of making a hole that the PLC understands that it's going to be talking through. Then we get connect, which is kind of just dialing up the end user and connecting to it. So it will make a connection. And then finally we got reading. And there's a lot going on here, but really most of it is just reading whatever comes in on the open socket for the current instance just gets thrown in this buffer. To demonstrate, I'm going to pull up my HMI, and then I'll pull up the test software, where every time I hit send, the data comes through. Currently, the only thing different from Checkweigher to this software is the IP address and port. Checkweigher has a different one. Port I'm using on the Checkweigher is port 2305, which if I make a PuTTY connection to, because this is really all it is making a PuTTY connection to my Checkweigher. So this is just a normal PuTTY connection over port 23. If I make proper commands, every time now I hit WD tests and send it to it, it will respond with WD OK, which was original how I was going to expect to do it, because I was going to have to do WD start. And then if the Checkweigher has a box run across it currently, then that data will fill in here. WD stop that connection. But instead of, WD test, WD OK, WD test, and then becomes OK, then you can start it, I created a port inside the Checkweigher that every time you connect to that port, it immediately just dumps the data to you without having to do this WD test, WD OK. It's automatic, and I created it on 2305. So same exact PuTTY connection, and then this time if something comes across it now, it will immediately, without all those shenanigans, it will immediately read it and function beautifully, and it works great. And I'll show you that in a second. Okay, so as I hit the start button, box is going to come down, and there it shows up in front of inside the PuTTY connection that we had. So you can see that both on port 23 and 2305 I get the same data. It's just port 2305 that I made. I have to do a lot less steps to get to the information I wanted. So now that I've gotten to show you the PuTTY connection functioning, I'll step you guys through how the auto connection works. So when the auto connect bit here, or button, gets toggled, immediately it just unlatches it pretty much disables all the messaging instructions that are going on in the background and just turns them off, because pretty much to make it more fail-safe, I decided to have the delete instruction be at the beginning of the connection protocol, where as I'm making the connection and dialing up, before it can do those two steps, it has to delete everything, so it destroys everything that's possibly there, and then builds a new, because I found a lot more stable and a lot more resilient to having, like, if the PLC processor faults out, if Checkweigher goes offline, those things, it's a lot more likely to stay through it. And I hit this button, so you can come down here and enable the delete all sockets, and then after 50 milliseconds, it's going to come down here, create new sockets, and then guess what? 50 milliseconds later, it's going to try and connect, and then 50-second delay, millisecond delay later, it's going to be told that you can start reading. So the second I come over here and hit this, all of them pretty much immediately flash, where now it's reading. So I can come over here, anyways, that will clean itself up. So, put back on auto connect. It's now connected to the server. Now I can send it a negative value. It has no problem reading it in the background. It's just a real value. You can pause the video if you want to read the whole thing, but in conclusion, I've learned a lot about how to communicate with hardware systems that aren't the most willing to disclose their information. Also, I've had plenty of experience on how the best plans will look great on a piece of paper with a month to spare, and then after things start to run over, time disappears as I need to learn how to finish my project with the time I have. Special thank you to Dale Milkey and Josh Rankin for being great instructors.